All right, today we're talking about integration by substitution. This is a very important skill for you to get a hold of and get an understanding of, because I would say probably about 75% of all the integration that you do from now on is going to require integration by substitution. It's not really that complicated. It's kind of like the chain rule. So that's where we're headed with it. We're going to work through lots of examples today and tomorrow, getting you a good understanding of this is what we mean by this. This is what integration by substitution is. I don't know if y'all have that link in your notes or not. You may want to go back and look at that on your own sometime, or we may kind of lead off some with it tomorrow. I haven't looked at it in a year, so I'm not sure. But here's our problem that we're dealing with, and you've dealt with this a little bit already. When we have to integrate something like x plus 1 squared dx, what do we do with that? We have to FOIL that out. We have to multiply it out, and then we can use the power rule like we've been doing. Well, and that's easy enough when it's squared. But what if it's a higher power? What if it's something like x plus 1 to the 5th? Could we still do that? Yes, we could pull out our binomial theorem and do our Pascal's triangle and figure out what it is and make it into 7 terms. But there's a much easier way to do that, and it's called integration by substitution. Now, to me, there's just a lot of algebra in this these problems, so I think you'll grab a hold of it pretty good. So I'm just going to work through this as an example, and let's see if you get an understanding of what's going on here. Then we're going to make some generalities as we go through. So we're going to start off by changing the variable, okay? We're going to let u be equal to x plus 1, okay? And don't worry about why. We'll get a better understanding of that down the road. Now, I've got a question for you. If u is x plus 1, then what is du, or the derivative of u? 1 dx, right? Are y'all comfortable with that? Or maybe let's write it a different way. I'll get to that in a second, okay? If I were to say find the derivative of u with respect to x, you'd say that's the number 1, right? Okay, now if we treat this as algebra, we can say that that means du is equal to the number 1 times dx, okay? That's kind of fuzzy to do that, but it helps us to understand it better, okay? So now I want us to go back over to our integral, okay? Do we have something that we could put in place of x plus 1? What could we put in place of x plus 1? We could put that thing right there in place of it, couldn't we? So let's just do that. We're going to replace x plus 1 with u. Well, now if u's a variable, well, let's don't say that yet. Do we have anything we could put in place of dx? Well, what could we put in place of dx? We could put du in there, couldn't we? All right? And all we did is just substitute one thing in for another. Now, step back. Do you know how to do that bottom one that's in green? What's the integral of u to the 5th du? That's just simply the power rule, right? So that would be u to the 6th over 6 plus c. But we didn't have u's in our original equation. We had x's. How could we get this back to being x's? Yeah, what could we put in place of u? We could put x plus 1 over 6 plus c. That is an antiderivative for that original thing, because what happens if you take the derivative? I forgot that exponent of 6. What happens? How do we take the derivative of this thing right here? We've got to use the chain rule, right? We're going to bring the 6 down. So if I wanted to take the derivative of that, we'd bring the 6 down. and make it x plus 1 to the 5th power times, what's the derivative of x plus 1? 1. And if we clean all that up, we get x plus 1 to the 5th power. Lo and behold, that was pretty straightforward, wasn't it? Okay? Let's look at maybe some other examples. I think before I get to that, I want to actually look at another example that I'm going to make up here. So let's see, what if we were trying to integrate nope, I'm going to change my mind. We're just going to go look at this next example that I've got here, okay? So, find the integral of x squared plus 1 squared times 2x. Now remember, I talked about from the very beginning, we don't have a product rule. So, the only way we can do this without substitution is to FOIL it out. We could FOIL this out and then multiply through by 2x and then integrate all of that. A lot of algebra involved in that. We're going to do that differently now, okay? We're going to start off and we're going to say let u equal x squared plus 1. And actually, I don't need the parentheses there. Just let u be x squared plus 1. All right, now, if u is x squared plus 1, what is the derivative of u? What's the derivative of this side over here? What's the derivative of x squared plus 1? 2x. So are we comfortable with what I've just written down there? Because normally we would write it as du over dx equals 2x. But then, and it's fine to write it that way. But for our purposes right now, and I can't really go into depth of why, we need to think of it this way. I think it helps us algebraically. du is 2x times dx. All right, now, how does that help us out? Now let's see, can we go back over here? What can we put in place of x squared plus 1? See, all I want to do is I want to see, what can I replace x squared plus 1 with? With what I wrote over here. I can replace x squared plus 1 with the letter u, right? U squared. I've got a 2x and a dx left over after doing that, though. Well, what do I have over here? 2x dx is the same as du, right? Can we integrate what we've got written here in red? Of course we can, because now it's just a power rule. What do we integrate it to be, Jared? 1/2x. U squared. Okay. Okay. All right, let's back up then. Do you understand? And getting this substitution is crucial, okay? I'm just looking at x squared plus 1 and saying, okay, well, we said x squared plus 1 was the same as the letter u, so we're going to put that in for u. Remember when we started talking about integrating, I said this du out here, or this dx, tells us what to integrate with respect to. So if we've got u's, we've got to have a du here. How do we get that? Well, what can we replace 2x dx with? 2x dx can be replaced with this. So think of it just strictly as algebra substitutions. We can replace the x squared plus 1 with the u, still squared because it wasn't part of that over there. 2x dx, look again, we can replace that with du. So we just get an integral u squared du. Now, if we integrate u squared, Jared, what are we going to get? 1/3, not x though, because we're integrating with respect to u. 1/3 u cubed plus c. But our original problem had x's in it, so how can we get back to x's now, class? We're going to substitute back in. We're going to say this is the same as 1/3 times x squared plus 1 cubed plus c. And if we take the derivative of that, again, we get to use the chain rule. We bring the 3 down, It's going to cancel out. So we'd have x squared plus 1 to the second power, because remember chain rule, we're taking derivative. We reduce it by 1 power times 2x, because the derivative of x squared plus 1 is 2x. So we get back to where we started from. How does that feel? Okay. I'm not going there just yet. Now I'm going to put in one for you to do on your own, okay? The integral of x squared, nope, take that back. The integral of x cubed plus 1 to the negative 5, 3x squared dx. X cubed plus 1, 3x to the negative 5, 3x squared dx. And we've got to integrate that. So who can tell me what they think the u should be? Very good. That's right. We're going to let u equal x cubed plus 1. Do you have any generalization now of what you should let your u be every time? How would you generalize that in words? What would you say? How do you know the 3x squared is not?
It's only one term, so that makes it like still in higher power, and
It's hard to think. Right now, you just know, right? We're going to get to better with it, but you just know right now. This is I look at it as what looks most complicated right now. The x cubed plus 1 to the negative 5, that looks complicated. Can I simplify that? Well, in fact, we can. U is x cubed plus 1. So then that means du is what? 3x squared dx, because the derivative of x cubed is 3x squared. All right, now if you need to write in the divided by dx, first of all here, and then multiply it over, that's fine. I'm not going to be writing that in because I'm at a time-saving mode now. So now we've got all of our u's. Let's see if we can go back and substitute in and simplify this. So x cubed plus 1, I'm going to put u in to the negative 5 power. I keep the negative 5 power because I didn't have it over here anywhere. 3x squared dx. That's what I've got here, 3x squared dx. So I can just replace that with du. That looks like a straight power rule to integrate, doesn't it? So it's going to be u to the what power when I integrate? Negative 4. So I'm going to divide by that same power plus c. So I'll get, I don't want u's though in my final answer. I want x's. So I'm going to go back and substitute in x cubed plus 1 for it, okay? X cubed plus 1 goes in place of u to the negative 4 over negative 4 plus c. And if I take that derivative, I should wind up back at my original thing there. Does that make sense?
3x squared, you multiply that to 2, right?
What, if I'm taking the derivative? Yes. If I were to go through and take the derivative of this thing right here, if I'm going to take that derivative, then I'm going to bring the negative 4 down. I've still got negative 4. I've got x cubed plus 1 to the 1 less power, which is negative 5, times the derivative of x cubed is 3x squared. And that's back to where I started from, because the negative 4s would cancel, and boom, that's what I've got. So that's just a check there. This is your final answer. This is just checking it out, okay? Well, let's look at this next one. It's got trig in it. So that just scares you right off, doesn't it? Makes you want to scream. Can you integrate that without the u substitution is your first thing to try. What function has 5x, cosine 5x? What function has 5 cosine 5x for its derivative? It's very hard to think about. Some of you are sharp enough you can think, okay, I can do this, and yes, that'll get there. Okay? But most of us, at least right now, we need to do a u substitution. What do you think u should be? Cosine 5x? Just 5x? 5x, okay? Let's look at them, okay? So let's start off looking at cosine 5x. If we let u be cosine of 5x, then what does du need to be? What's the derivative of cosine? Negative sine 5x times, we got to take the derivative of 5x, is 5 is dx. Does that look like the right way to go? I don't see a sine of 5x anywhere over there. So that, although that's a possibility, that looks scary to me because I don't know where I'm going with that. So let's go back. Let's say, no, don't like that. What if we said u is 5x? Then what would du be? 5 dx. Now that looks a little simpler, doesn't it? So let's see, can we go over here and do anything? Integration. Well, I got a 5 to begin with. What am I going to do with that? Okay, and this is where students sometimes, what'd you do here? This 5 and this dx, if you're thinking algebra, if you're thinking strictly algebra, okay, you don't know any calculus, what does 5 cosine x dx, what does all of that mean that we're doing with those things? Multiplying them, right? That means 5 times cosine 5x times dx, whatever all of that means. If we're multiplying, we can move the order of stuff around, can't we? So this is the same thing then as saying we got the cosine of 5x times 5 dx. So what can we replace 5 dx with? Du, way out here. Then, do we have anything we can put in place of cosine? No, but we've got something we can put in place of 5x, don't we? We can just make it the integral of cosine u. Now that looks like something that we can find an antiderivative for, doesn't it? What's the antiderivative for cosine? Sine, very good. So we've got the sine of u plus c. If we want to get it back, though, in terms of x's, what do we put in place of u? 5x. So we get the sine of 5x plus c. Now, at least in your head, if I were you, especially early on, I'm going to take the derivative. What's the derivative of sine 5x? It's cosine 5x times the derivative of the 5x, because we're using chain rule. Derivative of 5x is 5, so we get back to our integrand. So the integral of 5 cosine 5x is sine 5x. Okay? How are we feeling with this? It's not the hardest thing we'll ever do, but it has its challenges there. Okay? See if you can do this one without any help from me. I have confidence in your abilities. Marlon, what do you think u should be?
X squared plus 1.
Everybody agree with him on that? Hopefully you're getting to a point, or what do you need to be thinking? You really need to start thinking a couple of steps down the road, okay? If u is x squared plus 1, then what's du going to be? 2x. Do I see a 2x in there? That feels good then, doesn't it? So we know u is going to be that. Du is 2x dx. Now, I'll caution you, okay? What some students want to do is look over here at the actual integral to find their u and their du. All you need to figure out from this is what's your u. Once you figure out what your u is, now forget about the integral. Calculate your du from this, because we're about to get to problems where du is not over there completely. So du is 2x dx. Now, what does my integral in terms of u become? Anyone? Okay, that's my final answer. U to the 5th over 5 plus c. Here within the integral, though, we're just integrating u to the 4th, right? Is everybody there? Because what are we doing? We're replacing x squared plus 1. That becomes this u. This 2x and this dx becomes this du down here. And if we integrate that, we get u to the 5th over 5. Back to u's. X squared plus 1 over 5. X squared plus 1 to the 5th over 5 plus the letter c. All right. Good. Y'all got a good handle on this, I think. What do you think u needs to be there? U needs to be x cubed plus 1. Hopefully, some things are jogging in your memory that says, hey, this is kind of like chain rule for derivative. It is chain rule backwards. You know, do you remember when we did chain rule, how did we figure out what was the inside function? Do you remember? The inside function was whatever was inside. It's whatever's in a parentheses. It's inside of another function. So the same thing here. What's inside another function? X cubed plus 1 is inside a square root. So that's a good place to start, letting u be x cubed plus 1. And then we can proceed from there. Finish that off and see what you come up with for an answer, and then I'll give you my rendition of the answer in just a moment. Marlon, y'all got basketball tonight? Mm-hmm. Against?
4 days this week.
Oh, boy. That makes for a fun week.
Mm-hmm. Yeah, so tonight is Lakeview.
Here or there?
Here.
Okay.
Actually reminds me. Them and Tallulah, the 2 undefeated teams, played last night.
Okay, so if u is x cubed plus 1, then again, looking at what I wrote in green, du is 3x squared dx. Now I can look back over there and see, is it all there? If it's all there, then I'm in a happy place. Well, I'm going to replace x cubed plus 1 with u to the 1/2 power, because that's what square root is. This dx and this 3x squared, I'm going to think of them as multiplied together, so I can just replace them with du. So suddenly I can integrate that. That's u to the 3/2 power divided by 3/2 plus c. If I don't want u's in there, which we do not, is 2/3 x cubed plus 1 to the 3/2 plus c. Okay. Good, good. Y'all got a great understanding of this, it feels like, so far. So, what happens here? Secant squared x times tan x plus 4. Both of those look pretty complicated to me. What do you think your u should be? U is x plus 4? Well, now, this tan x is here, and then after you take the tan, then you're going to add 4. That's the way to read that, okay? Should your u be x? Should it be secant squared x? Should it be tan x? Should it be tan? What do you think? Mary says tan x plus 4. Why, Mary? Because what are you going to get with if you take the derivative of tan? If we go back and remember, or we look it up, we get secant squared x dx. If we try to let u be anything else, it doesn't seem like it'll help us out any. If we let u be secant squared, what's the derivative of secant squared? It's 2 secant times tangent, 2 secant times secant tangent, or something like that. I don't know. So anyway, it doesn't help us here. This looks like it would help us. Again, even though both of these look complicated, the tan x plus 4 is inside a parenthesis. So that's a good place to start off there. And sometimes you're going to guess wrong and have to start over again, okay? It's okay to do that too. So u is tan x plus 4, du is a secant squared. So then what do we end up integrating? In place of tan x plus 4, we're going to put u. In place of these two, we're just going to put du. Wow, that's a whole lot easier looking thing to integrate, isn't it? So suddenly we see that that becomes u squared over 2 plus the letter c. And in place of u, we can put tan x plus 4. The whole thing squared divided by 2 plus the letter c. Tan x plus 4 quantity squared divided by 2 plus c. Do we get an understanding of this a little bit, maybe? Try this one, and then I'll help you out with it in a second. But try it for a moment first. When you see the problem, then start figuring out how to solve the problem. Do you have a problem? What problem do you see if you see one? Yeah. So you let u be x squared plus 3. I mean, that makes sense with everything we've done so far. It's inside of another function. So if we let u be x squared plus 3, then du is 2x dx. And that's where you say, what's my problem? I don't have a 2x over there anywhere. Well, that's a bummer.
I'm going to say to the left side.
Very good. What if we did this? Is that still a true statement algebraically? Okay? That is a true statement algebraically. So now, that makes us a little bit happier over there, don't we? Because now, what are we going to do? We're going to integrate, and in place of the x squared plus 3, we're going to put u to the 4. And then in place of the x dx, what are we going to put? 1/2 du, okay? All right? Now, I wrote it like that, but what's the best thing to do and what you should get to the point that you can do is now, remember on this, over here we're thinking all of these are really being multiplied together so I can move them around wherever I want. And if you'll go back and look, anytime we've got a constant number, we can actually bring it outside of the integration sign. So I'm going to bring that 1/2 out in front of the integral and make it u to the 4th du. Now it's something I can integrate rather easily. I just got to remember to multiply it by half at the end. So I know I've got a half. Then I'm going to integrate u to the fourth. That becomes u to the fifth over 5 plus c. And if I want my x's back in it, I'm going to get 1 over 10 times x squared plus 3 to the fifth plus c. And if we want to check to see if we've got the right answer, we take the derivative of that. If we take the derivative, let's think about that. We need to practice taking derivatives from time to time. The derivative of that thing is, I've got the 1/10. I'm going to bring down the 5. X squared plus 3 to the fourth power times the derivative of x squared plus 3, which is 2x. Well, I've got a 2 times a 5, which is 10 on the top and a 10 in the bottom. So they'll cancel out. I get x squared plus 3 to the fourth times x. Lo and behold, that's what we started with. So this in the green box is the antiderivative for that. Now I have a question for you. We needed to divide by the 2 here, or we needed to get the 2 over to the other side, so that's what we did. Algebraically, could we have divided both sides by x if we needed to? Algebraically, from an algebra perspective, would it be just as simple to say 1 over, just as right to say 1 over x du equals 2 dx? Yeah, it's the same thing. We're just dividing by something we've got there. And this may be hard for you to see. What would be the problem with trying to integrate that thing that I just wrote down there? We got u's and x's in there. When you get into Cal 2 in college and Cal 3, you'll learn how to integrate when you've got multiple variables. We can't do that right now. So if you ever are faced with having something written like this on your paper, you are wrong. You can't do that, Ryan. You are wrong. You can't do that. You cannot, you've done something wrong if you're at that point. You can divide by a number, 2. You can divide by 2, you can divide by a constant number, but you can't divide by a variable. Okay? Just a little bit of an information there for us. All right. I'm going to stop right there. We'll finish off the rest of these tomorrow. There are 2 homeworks on this here. The first one's only got about 4 problems. I think it would really do good for you if you went through and did those 4 or 5 problems tonight. They're very similar to what we just did here, just so you've got a little bit more practice before we come in here tomorrow. Because when we come in here tomorrow, we're going to continue on with this and keep moving forward with this material right here. All right.